Good afternoon, all. Am I audible? Am I audible?
Yes, sir. Yes, sir.
Okay. In this lecture, what I am going to do is I will revise some of the concepts that has been covered till now and how to apply them for various calculations that we are going to see. So, you know the equations for the values like GM and RO. Most of the important parameters are these two in almost all circuits. So RO is given by 1 upon lambda ID, where ID is the bias current, while GM, you can write it as mu n C ox W by L into VOV, or other way of writing is square root of twice mu n C ox W by L into ID, or the third important expression is twice ID by V over drive. Right, 1 upon lambda ID, and you should understand that this lambda is proportional to 1 by L. If I double the length, lambda becomes half. If I double the length, lambda becomes half. So accordingly, it depends on what bias point is there. VOV is again capital VGS minus VTN or VTP, whatever you have. So again, these are DC values. So these parameters are decided by DC quantities, that is bias voltage and bias currents. Okay, so now if I come to NMOS, it's a actually 4-terminal device, but the 4th terminal body is not taken into account. If body terminal is there, and if there is a voltage difference between gate and source, there is a body effect. But we have not seen till now what is the body effect. I am not going to cover it right now. This is a gate, drain and source. So it is a symmetric device. The terminal out of this drain and source, the terminal which is connected to the highest potential for NMOS is always drain, and which is connected to the lower potential is always source. So for example, if I make the connection something like this, if I connect it to ground, and here if I plus 2 volt, then I should call this as a drain, this as a source. So for NMOS, always the highest potential is on drain, lower potential is on source. For PMOS, highest potential is on source, lowest potential is on drain. So accordingly, the connection should be made. Now coming to the point of what is the impedance that is there when you look from different terminals. So it is very simple thing, that is, see, these results are not obtained directly. They have been derived from small signal model and used as an equation when solving the problems. So for example, if I take NMOS, in any configuration, suppose I have to find out what is the impedance looking from source terminal. So normal method is you should apply the known voltage source Vx from here and find out what is the current drawn from it, and Vx by Ix will be the actual resistance looking from this terminal. When you calculate it, theoretically, practically not possible. Theoretically, you should remove all the sources. So if it is a voltage source, should be short circuited. If it is a current source, it should be open circuited. I am talking about independent sources. Dependent current sources, they cannot be removed like this. What are the dependent in case of small signal model? For example, this is a source terminal, this is a gate, this is a drain, and we write this as GM into VGS. The current through this depends on voltage here. So this kind of sources I cannot open circuit or short circuit unless and until I know whether VGS is 0 or not. Okay, so independent voltage sources and current sources are made 0. So voltage source is short circuited, current source is open circuited. Now in order to calculate it, what I will be doing is I will be connecting this to ground, I will be connecting this to ground. because generally VDS is applied to the drain, VGS is applied to source, some V in is applied to the source. Now, if I say that there is a resistance of 1 by Gm between gate and source terminal. Now, remember that there is no external resistance like 1 by Gm is connected. But the effect of what is happening here, if I change VGS, the current through this will change. Now, all are removed in calculation of resistances, both AC, DC, everything is removed. In calculation of gain, it is not done in that way. I will come to that point. I am talking about only resistance calculation. Okay. Now, VGS is a voltage and GM VGS is a current. What is the relationship between voltage and current? Voltage divided by V equal to resistance. So you can see that this is the voltage VGS upon GM VGS is the resistance R. So it is 1 by Gm. Now, the problem here is 1 by Gm is not simple resistance that we look into practical circuits. It is a trans resistance. When I change a voltage between gate and source, the current through drain changes. So that's why it is called the trans resistance, and it is modeled as a resistance between 1 by Gm. Okay, so when I change the voltage here, this is VGS. When I change the voltage here, current here changes between drain and source. So that is, this current is not changing. You should understand. This current is not changing. Current through MOSFET changes. So that is called as trans resistance. And where is the RO present? RO is between drain and source in this case. Right? Now you see, is 1 by Gm and RO, are they in parallel? Are they in parallel? See, this terminal is common. Where this terminal is connected to ground? Where this terminal is connected to ground? So they have same voltage across them. When same voltage is there across them, they are in parallel. When two components are in series, when they carry equal current. So you should first ask the question whether they are having same voltage across them or whether they are carrying the same current through them. If voltage is same, it's a parallel combination. If current is same, it is a series combination. Now in this case, 1 by Gm and RO, they are in parallel. So when I look from source terminal, it is 1 by Gm and RO. But if I add now, suppose a resistance here and ask you to find out what is the resistance looking from this terminal, that is R in from this side. Now in this case, now this is VDD. Okay, so this is connected to ground, this is connected to ground, this is RD. Okay, 1 by Gm is present here, 1 by Gm. Here there is a RO. Now, the common mistake that is done by the student is what they do. It is, if I ask you to calculate, some student will write 1 by Gm parallel RD plus RO. This is absolutely wrong. 1 by Gm parallel RO plus RD. Now you tell me why it is written RD plus RO. Are they in series? Are they in series? RD and RO, are they in series?
No.
No. They are not in series. You should understand this very clearly. Okay, they are not in series. The reason is, if I apply the known voltage source here, so this current is Ix. What is the current flowing through RD? This current plus this current will be the current flowing through RD, right? What is this current? What is this current flowing through the MOSFET? What is the current flowing through the MOSFET?
Right.
No, it is Gm into VGS.
Yes, sir. Yeah.
Gm into VGS is the current flowing through the MOSFET. And what is the current flowing through RO? It will be Vx minus voltage at this point divided by RO, right?
Yes, sir.
Right? And what is the current flowing through RD?
So some of them.
Sum of them, which is equal to Ix, right?
Yes, yes.
Okay, now again I am drawing this circuit. If you understand this concept, everything is very simple, right? Suppose if I am writing like this is 1 by Gm. Okay, so this is Vx and this is Ix. This is RO. Okay, and then there is a RD. This is connected to ground. Okay, RD. Okay, what is the current flowing here in this direction? Nothing, right? 1 by Gm is not practical resistance. What is the purpose of connecting 1 by Gm?
So it provides a model for the transconductors.
Model for transconductance, right? So actually, when I change a voltage here 1 by Gm, the current flows in this direction. Okay. If I know the voltage across gate and source, I will be able to find out what is the current flowing. What is the VGS now in this case? Can you tell me what is the VGS? What is VGS now?
Vx.
Vx or minus Vx?
Minus Vx.
Minus Vx, right? So Gm into minus Vx is the current flowing the MOSFET in this direction. How to absorb sign? How to absorb sign? I should change the direction, right? Should I change the direction?
Yes, sir.
So I should write now it as GMVX. GMVX is this current. What is this current? What is the voltage at this point?
Vx.
Vx. What is the voltage at this point? What is the current flowing through RD in this direction?
Ix.
Ix. So what is the voltage at this point?
Minus RD.
Minus Ix.
No, Ix RD, na?
Or
Minus.
Why minus? Plus, na? Current is going up. Ix RD minus Vx divided by RO, right? Divided by RO is the current flowing through RO. What is the current flowing through the MOSFET? What is the current flowing through the MOSFET proper? GMVX plus GMVX. This addition of these two should be equal to what? The current Ix, right?
Yes.
Current Ix. Now you solve it. So Ix related terms, if I take it on one side, Ix, it is 1 plus RD by RO, right? Sorry, just 1 minute.
It should be Vx minus Ix.
Vx minus?
IXRD.
Vx minus Ix, sorry. This should be, current is flowing in up direction, right? So it should be Vx minus IXRD divided by RO should be this, right? Now Vx related term, if I take it 1 upon RO plus Gm, on the other side Ix in bracket 1 plus RD by RO, right? So what is Vx by Ix now? 1 plus RD by RO divided by 1 by RO plus Gm. So what is the value you are getting here? RD plus RO divided by 1 plus Gm RO. Somebody will say that this is very difficult to understand. Remember this equation. So I generally say that there is some rule called as a resistance transformation rule. I will explain it, you understand it, and then apply it. Okay? It is called the resistance transformation rule. Okay? What is that? Suppose I have this configuration V in, okay, and this is VDD, this is V out, this is RD, this is RS. Suppose if I ask you what is the resistance looking from this terminal R out, what is the output impedance? Can anybody tell me what will be the output impedance? See, for finding out the impedance, what should be done? What should be done? I should apply this. So this will be connected to ground. This is connected to ground. This is connected to ground already. And I should apply the known voltage source here. I should apply the known voltage source here. And find out what is the current drawn from it. So this is Ix. Okay. Where the Ix will be divided into two components, right? One is going up, another is going down. So the resistance, because of the current that is going up, I will call it as R up. And the current, because of the current that is going down, I will call it as a R down. Okay? What is R up in this case?
RD.
RD. Resistance is RD. What is the resistance in the downward direction? If RO is there, if RO is there, what is the resistance in down direction? While going from, you are looking from source terminal, it is a source degeneration, right? It is a source degeneration. So this resistance will be GM. No. That's the problem now. Okay. So suppose I have to find out a down resistance only. Just see here. So this is connected to ground. So what you have done, you have applied a known voltage source Vx. This is very important. If you don't remember, understand this, it will be really difficult for you. You remember this, what I am saying. Now suppose this is the resistance RO. What will happen? What is the current that will flow through RS? What is the current that will flow through RS?
IX.
This current plus this current will be equal to Ix, right? Ix. Ix is the current that will flow through RS. Okay, what is the MOSFET current? This, the arrow that has, it is GM into what? VGS, right? This current must be GM into VGS. Okay, now you tell me, VGS I have to calculate. What is the drop across RS?
IXRS.
IXRS. So the voltage drop across this is IXRS. Okay. So can you tell me now what is VGS then?
Minus IXRS.
Minus IXRS. You understand this? Anybody have not understood how it is? Because if you apply the Kirchhoff's voltage, suppose if I call this as a VGS. Okay. So I will say this is the voltage drop across RS plus this is VGS. This is the source terminal, right? So it is VGS. So you can see VGS plus VRS is equal to 0, right? Voltage, Kirchhoff's voltage law has been applied. VGS plus, what is the VGS now then? VGS is equal to minus VRS. And what is VRS? What is the drop across RS?
IXRS.
IXRS. So it is minus IXRS. So the current flowing in the direction, downward direction is what? Minus IXRS into GM. Right? minus Ix Res into Gm. What is the current flowing through RO? What is the voltage at this point? Vx. What is the voltage at this point?
IS.
Ix Res, right? So can I write the current flowing through RO is Vx minus Ix Res divided by RO is the current flowing through RO. And what is the current flowing through MOSFET? You already calculated this. What is this? Minus minus Ix Res Gm, right? What should be the addition of these two current?
IX.
IX.
It should be equal to Ix. Okay, so can I take all Ix related term on one side? Vx divided by RO is equal to Ix. What is there in the bracket? 1 by RO plus GMRS plus 1. Agree? Agree? Is it correct? So what is Vx by Ix, you tell me? RO multiplied by 1 upon RO plus GMRS plus 1. So if I multiply it inside, it will be 1 plus GM RS RO plus RO. Is anything missing? I have missed it here.
Sir, RS. Should be RS by R.
So it should be RS by R naught.
Yeah, the first term is right hand side.
First,
So the
first,
second, when you took Ix common, the first term,
okay, it should be
RS by R.
RS by R naught. Okay. Now, right? So it will be RS. Okay. So it is RS plus RO plus GM RS RO. Actually, I missed it. Okay. Vx by Ix. What you were saying initially? What you were saying initially? It is RO plus RS. Is it possible?
No, sir, because the currents are not the same.
The currents are not same. They are not in series. So, what you said? Okay. When you, somebody is now saying that if I look from the drain terminal, the resistance I said RO, but when RS is absent, if RS is present, then it is altogether different equation. If RS is not present, if this is connected to ground, the resistance looking from the drain terminal is only RO. Understood? Somebody asked me question now. Okay, if RS is present, if any resistance is present, so this is called the source degeneration. This is called as a source degeneration. Okay, now here I am going to tell you a rule, what the rule says, which is called the resistance transformation. Okay, now from this, can I say if I take suppose RS constant, sorry, RO constant from this here, RO common factor, what is there in the bracket? Or suppose if I take RS common, so I will write this expression as same RO plus RS plus GM RO RS. Suppose if I take RS common, what is going to happen here? In the bracket 1 plus GM RO. Can you tell me what is the relationship between 1 and GM RO, which is a very large quantity? Out of this to 1 plus GMRO?
GMR.
GMRO is very huge quantity. RO is in kilo ohms, 100 kilo ohms, sometimes it is in mega ohms. while GM is value like 20, 30. So you can understand that this product will be, even though millisiemens, it is very large in comparison to 1. So in most of the calculations, this 1 is neglected and you get it as RO plus RS GM RO. Now if I take RO common, what is going to happen? It is 1 plus GM RS. And in most practical situation, again this 1 is neglected. So this value is assumed to be RO RS GM or GM RO RS. I will come to this point, RO RS. Okay, so this is approximate value, this is exact value. Okay, RS plus RO plus GM RS RO. You remember this equation, RS plus RO plus GM RS RO. And in approximation, these two are neglected, only this GM RO RS. So if I ask you, suppose for example, this is circuit configuration. VB, this is V in, and some circuit is there. Suppose resist. This is connected to ground. This is suppose R out. You are looking from this. What is R out? Looking from this terminal. It is R up parallel. R up parallel.
R down.
R down. What is R up? What is R up?
So RD.
RD. Okay. Now I have to find out R down. Now you tell me, where is the source terminal of this MOSFET M2 is connected? Is it connected to ground? Is it connected to ground?
Okay.
No. So what should I do? I should look from this terminal and see what is the resistance offered by M1. What is the resistance offered by M1 when I look from the drain terminal into M1?
R01.
RO1. Why? Because this is connected to ground. In finding out the impedance, this is connected to ground. Where is 1 by GM present? 1 by GM is present between these two terminals, right? Between gate and source, always 1 by GM. But you can see in this case that both the terminals of the resistance 1 by GM, they are connected to ground. So it is short circuited. So this will not come into picture. What is remaining now? RO1. So what is the resistance looking from the drain terminal of M1? RO1. So I will replace this by a resistance is equal to RO1. Okay. Now for M2, RO1 becomes
RS.
RO1 becomes RS. What is the formula for now? RS plus RO plus GM RS RO. RO1, RO2, that sequence doesn't matter. This is the impedance. When you look from, this is R down. This is the exact value. What is the approximate value? What is the approximate value?
GM2, RO1, RO2.
GM to R01.
RO1, RO2. Looking from this. Understood how to calculate resistance in case of source degeneration? Understood how to calculate a resistance looking from the drain terminal when RS is there? Any question?
So previously you had discussed an example, a similar one. I was able to note it down. Could you scroll to that one? Where you had calculated, I think, you had applied like Vx to the source, and then you had seen the current that goes. Could you show that example?
Which one? This one? This one?
No, sir, not this one. It was, I think, the one that you discussed after this. No, before this one. Sorry, before this.
This one.
No, sir, you had applied the Vx to the source.
Okay,
Yes, sir, this one. Yeah, could you just show the calculation for this? I was not able to note it down.
So it is Vx minus IXRD. This voltage, so this voltage minus this voltage divided by RO, the first term.
Right. Yeah.
Okay, and second term is the current flowing through the MOSFET proper, which is GM VGS. Here VGS is minus Vx, so I changed the direction of the arrow and make it plus GM VGS.
So you've taken Vx minus IXRD there, right? Okay, yeah, got it, sir.
Okay.
Sir,
Ah.
yeah, so generally the current through MOSFET is in the downward direction, right? So here,
Downward, but my VGS. So you
yeah,
should
in
not.
this case Vx is opposite.
So you should not confuse between instantaneous current and AC current. Okay, suppose I have a current, so you should understand this concept, what I am saying. Suppose this current is 0.1 milliampere. This is a DC current. Okay, now over it, what will happen? AC current will be superimposed. Suppose if the AC current increases by 0.01 milliampere, what this current is going to become? 0.11 milliampere, right? And if the AC current reduces by a value of 0.01, the same current will become
0.09.
milliampere. So in both the cases, current is flowing down. But when I talk in terms of only AC current, I say that the current flows in the upward direction. Understood? Understood what I said?
No, sir.
Say this is a DC current. So if, because the new current adds to it, so this is 0.1 milliampere. So new current 0.01 milliampere adds to it because of some other source. This current is, what is the value it is going to become?
0.1.
0.11 milliampere, right?
Yes, sir.
And if suppose because of some reason the current decreases by 0.01 milliampere, what this value is going to become?
0.09.
0.0. So in both cases, current is flowing in the same direction. One is 0.11 milliampere. In another case, it is 0.09 milliampere. I am not changing the direction of a current. But what I am assuming is the DC current is absent. In that case, it is just the assumption. So in one case, the current of 0.01 will flow in the downward direction. The other current will flow in the upward direction.
Okay, sir. Yes, sir.
So this is just a concept. Okay.
Yes, sir.
Current always flows from, because only AC current is not possible. Circuit is not going to work. DC plus AC. Out of that only I am considering AC component or whatever the current IX that I am assuming. Okay.
Yes, sir.
This is not any kind of a real voltage or a current. It is just the assumption that I am applying the known voltage source and finding out what is the current drawn from it to find out the impedance. Okay.
Yes, sir. Thank you.
Okay. Now, so I am now explaining you what I said about the resistance transformation rule. Okay. So what I will say. Suppose now you should understand and don't get confused. Okay. So now suppose I have this kind of a circuit. This is a RO. Okay. And suppose you have to look from this R out, from this side. I am talking about only R down. Okay. If the source resistance is to be transferred here in series with RO, it should be multiplied by 1 plus GM RO. So it becomes another resistance here. You should remove from here. It comes here and it becomes RS multiplied by 1 plus GM RO. So what is the total resistance becomes in the downward direction now?
RO plus RS.
RO plus RS plus GM RO RS. What I said, when RES is removed from there, it should not be done practically. It is practically not possible. This is just to remember the formula. RES should be removed from there and should be put up in series with RO. It is multiplied by 1 plus GM RO. Understood what I said? Understood what I said? It is multiplied by 1 plus GMRO and exactly opposite. Suppose now here you should understand that the total resistance R out will be R down plus R up. R, because I am looking at this point. So you can say this resistance is between this point and a ground. This also between this point and a ground. Suppose here this is VDD. Suppose this is RD and there is a RO. Now suppose you want everything to be transferred on the source side to look from here. In previous case, what we have done, we multiplied by which factor?
Sir, could you repeat your question?
What I said, when I transferred RS into series with RO, by what factor I multiplied?
1 plus
1 plus
GM.
GMRO. Here I will do the exactly opposite. I have to bring both RO and RD both here. So I will divide both by 1 plus GMRO. So what I will be getting equation? RD plus RO divided by 1 plus GMRO, which is the equation that we have got previously, right? Which equation? This equation that we derived, right?
So this works for both RD and RO. So like even the drain, anything if it's connected to the drain, we can bring it to source.
Yeah, source, anything connected to the drain should be divided by 1 plus GMRO, and RO should be also, now this becomes a resistance here. Okay? Looking from the source terminal. It is when this rule should be applied. When this rule should be applied, when RO is present, okay? If RO is not present, now I will ask you one question. If RO is not present, this is say V in, and you have to look from this terminal. This is connected to VDD. If RO is not, this RO is not present. Oh, not present means what is the value of it?
Infinity.
Infinity. So when you have to look from this, now what is the impedance? Can you tell me? What is the impedance looking from this? What is the resistance present between these two terminals?
1 by GM parallel RD.
1 by GM. 1 by GM. Will RD come into picture? Will RD come into picture?
No.
It is not visible for me, right? If RO is not present, RD is not visible for me. You should understand through this small signal model. What I have done is I connected gate to the ground. This is plus minus VGS. This is GM VGS. And RO is absent and there is a RD between this point and the ground, RD. And now I connected a known voltage source Vx plus minus Vx, and this current I call it as Ix. What will be Ix? What is Ix? Ix will be equal to Kirchhoff's current law.
Minus GM.
Minus GM VGS. What is VGS? Vx. Minus Vx, right?
Yeah.
VGS is minus Vx. So it is GM Vx. Ix. Is RD coming into equation? Is RD coming into equation?
No, sir.
When RO is absent, If I connect RO, then there is a altogether different situation. RO. Now in this case, current Ix will flow through this, and what is current Ix now? Ix is simply addition of this plus this. Previously when this was absent, Ix is simply Gm VGS. So whether RD is present or not, it is not visible to me. If RO is present only, then it is visible. Is it clear? Is it clear? Okay. Very important topics, and you should understand to apply them while solving the examples.
Sir,
Huh.
when we were performing the transformation from the drain to the source, we divided by 1 plus GMRO, right? So in this case, the total resistance, we can just take it as RS plus RD plus RO upon 1 plus GMRO.
Yeah, if RS is present here.
If R is present, okay. So that will become the total resistance as seen through drain and source.
Yeah.
Okay, got it. Thank you, sir.
Okay. Any other question? Any question that not understood? Anything you want it to repeat? Anything? Any question?
Sir, I didn't understand how we wrote the RS as RS times 1 plus GMR.
RS as?
RS times 1 plus GMRO in the previous.
This is a way to remember it. What I said. So I'm drawing it here, a simple circuit, and I will write all the rules what I said. Okay. Suppose this is the circuit and RO is present. Okay. Now the problem here is, if I look from here, which we call it as a R out. R out is because this is connected to ground. The impedance between this point and the ground. Now there are two paths. One is here from ground and another is from here to ground, right? Now how to remember the equation for R down? The simplest way is this RS. It should be removed from here and should be placed here in series with RO. What is the rule? This RS should be multiplied by its GMRO, 1 plus GMRO. This is a way to remember it. There is this transformation rule is really not applicable. So what becomes now? This is removed. So this becomes now 0. This is RS into 1 plus GMRO. So what is the R down now? What is R down now? RO plus RS into 1 plus GMRO. Understood?
Yes, sir. Thank you.
And this is the equation that we got it previously when I solved it by small signal by writing all the equations and all. So this is the equation that I was talking about. Okay. And when sometimes I require to find out what is the impedance looking from this. What should I do? This should be brought here. This RO should be also brought here. So RD is divided by 1 plus GMRO because previously what I have done, I have multiplied by 1 plus GMRO, right? Now I will divide by 1 plus GMRO to get the equation. So it is same as RD plus RO upon 1 plus GMRO. This is the second equation we got it when you looking from the source terminal in the presence of RO. Clear?
Yes,
Is
sir,
it
thank
clear?
you.
Okay. Any other question?
So when you say looking at the source, do we have to look above RS or below RS?
So if suppose already some resistance is there here, then see. Okay, suppose I am V out here, okay, and suppose there are two ways I have to look into it, in the sense that Suppose if I am looking from this side, because this is suppose connected to ground. If I open the ground and apply the non-voltage source here, then it will be Rs plus, what will be the resistance here? If I transform this and this here, what it will be? Rd
plus RO
Plus
divided
RO.
by 1 plus GMR.
1 plus GMRO. Okay. But if somebody asks you what is the resistance between this point and a ground, what it will be? Can you tell me now? What is the impedance? What is the
The
resistance
point that you marked and ground.
here between this point and a ground?
So it will be
RS will be parallel.
RS parallel, that parallel combination, right?
Yes.
So you have to look at which point you are actually calculating the impedance. But again, I am saying this technique should not be applied for gain calculation. The gain calculation formula that I told you, that resistance connected at the output divided by resistance into the source terminal, it should be only applicable when RO is absent. Okay, by doing this transformation, you should not apply the rule. Please keep it in mind. This is only for resistance calculation.
Sir, here when you told when seen through the source terminal, you mean to include RS or not?
Through this, so it will be pointed out, right, from where you are actually looking. Suppose my input is applied here and somebody asks you, what is the purpose of calculating input and output impedances? What is the purpose of calculating input and output impedances? Because when you are connecting your amplifier to any load, if your output quantity is a voltage, should be represented by what? Thevenin's equivalent. If output quantity is a current, it should be represented by Norton's equivalent. And what is there in Thevenin's equivalent and all? Impedances, right? Right or not? So there are two cases. One case is I am applying the input at this position. The second possibility is I am applying the input at this position. This is Rs and this is Vin. Now what is the impedance looking from the input terminal now? Rs plus that quantity, right?
Yes.
And here in this case, Rs parallel that quantity, right?
Yes.
So it depends on where you are actually applying your inputs and all, from where you are taking the output.
Okay, sir, got it. Thank you.
Okay. What is the next question now? Understood these concepts?
Sir, so can these be used to calculate R in also or only R out?
No, both R in and R out.
Okay, sir. Thank you.
Both R in and R out. It can be applied. Not an issue. Okay. Any other question?
Sir, I have a doubt in differential amplifier.
Okay. I will come to that point, differential amplifier. Before that, now, in order to improve the gain, I will come to that point, okay? I will come to that point. So, somebody said, what is the method of calculating? Because in, you have seen this amplifier, right? Have you seen this amplifier? This is VB3, VB2, VB1 and Vin. Have you seen this amplifier?
Yes.
Yes.
This is V out. What is it is called? Cascode. Okay. What is the meaning of a cascode? Cascode is common source amplifier followed by common gate amplifier. Okay. Because you can see Vin is applied here. If you take the output here, what is happening? Which kind of amplifier it is?
Common source.
Common source, right? Common source amplifier. And what is Now you can consider the output of M1 is connected as a input to M2's source. So what is the configuration it is?
Common gate.
Common gate. So common source amplifier followed by common gate amplifier is called as a cascode. Now in this case, how to calculate a gain? Okay, first I will ask you what is the output impedance of this? Output impedance of this. So output impedance will be R up parallel R down, right? Can you tell me what will be the value for, what will be the equation for R down? Exactly, you write it first and then approximate. In exam you can write approximate value, but what is the exact value? Can anybody tell me immediately?
So is it
What
GM
is
R1 R2?
What is RS?
Sir, RO2 plus
What
1
is
plus
RS? RO1 is RS, right?
Yes, sir. RO1 plus RO2 plus GM RO1 R2.
RS plus RO, because this is now device and RO1 becomes is RS plus GM2 RO1 RO2 is R down. What is the difference there in the upward circuitry? Is it the same? Is it same?
Yes, sir, it's PMOS.
But it is a PMOS. That's the only difference while calculating, because anyway in calculating the impedances we are connecting this to ground. This is also connected to ground. This is also connected to ground. So there is no difference. Can you tell me what is R up?
So RO3 plus RO4 plus
What is
GM3
RS,
RO3.
what is RS here? What is RS in this case?
RO4.
RO4. So it is RO4 plus RO3 plus GM3 RO3 RO4, right?
Yes, sir.
Okay. So in many books you will find out that they write only GM3 RO3 RO4. So this factor they generally don't write. Similarly, this is written as GM2 RO1 RO2 approximately equal to. This is okay, means even in exam you can use it. Understood? So what is R out is GM2 RO1 RO2 parallel GM3 RO3 RO4. These are out. Okay. How to find out capital GM? Because gain calculation method is capital GM into R out method, right?
Yes, sir.
Okay. So what is the way of calculating capital GM? What should be done?
So we ground V out, apply a V in, and then check what R out is. Sorry,
Yeah.
I out is.
Okay. So now see, this is now if you understand this, all other concepts are like for calculation of gain are really simple. Now I will do that and you tell me if you have not understood anything. Now suppose I have to find out. So I found out what is R out. I found out R out. I have to find out now capital GM, right? So V in is here. What should be done about other voltage sources? It should be short circuited. Current sources open circuited. And output terminal
So grounded.
grounded. And the current drawn from the ground is I out. Agree? Now you tell me, will current flow through M4 and M3?
No.
No. What is the reason? Because this terminal is at ground. This terminal is at ground. So no current is going to flow through this. So this I will remove it from the circuitry because they are not going to take part into the circuitry. No current is flowing, so I will remove them. Right? Understood? Okay, now I will put RO here, RO2 here and RO1 here. Right. Now you tell me which is the current source in this case. Which is the current source in this case? Which is the current source here in this case?
So input.
Input, right? GM VGS. So GM1 into Vin. For this device, you can see what is the VGS? What is the VGS?
So V.
Vin. So it is a current source. Should I replace it by current source now? So this is the current source which is equal to GM into Vin, GM1 into Vin. Okay. Now, this current is divided into two parts. One is going down and another is going up. Another is going up. Which is the current that is going up? Total current that is going up.
IOT minus GM1.
The total current that is going up is flowing through 1 by GM2 and RO2, right? Where is 1 by GM2 present? Here, right? This is 1 by GM2, right or not?
Yes, sir.
And where is RO2? So 1 by GM2 and RO2, are they in parallel?
Yes.
Yes, sir.
1 by GM2 and RO2, they are in parallel. Somebody will say that RO1 is also in parallel. I will not consider it. The reason is I will tell you what is happening. So we have something like this. Now you should understand. So this is your one GM1 into Vin. There is one RO1 and there is another resistance which is 1 by GM2 parallel RO2. And can you tell me from this circuit which is the current IO2, or sorry, which is the current IOut? Which is the current IOut? Is it flowing through RO1 or is it flowing through 1 by GM2 parallel RO2?
1 by GM2 parallel.
Because you should understand that the current flowing through 1 by GM2 is actually this current, right? And the current flowing through RO2 is this current. Addition of these two should be equal to, if my sign is wrong, I will get a negative sign. That doesn't matter. Understood what I said? Addition of this two current is I out. So the current that flows through this is I out. Right? Do you agree?
Yes, sir.
Now you tell me which rule I can apply to find out I out. Current division rule, right?
Yes, sir.
Can you tell me what will be the equation for I out? GM1 V in
To RO1,
into RO1 divided by
RO1 plus 1 by GM2 parallel.
RO1 plus 1 by GM2 parallel RO2. Agree? Understood? Understood the equation that we have written?
Yes, sir. So I have one question. Why did we say that RO1 and GM1, RO1, 1 by GM1 and RO2 are not in parallel? Is it because different currents are
No,
flowing?
because the current flowing through, they are in parallel, but I am not interested in voltage, I am interested in current. I am interested in calculating current I out. I am interested in current I out. Which is the current I out? Whether flowing through RO1 or 1 by GM2 parallel RO2.
1 by GM2 parallel. Right.
Here also I have drawn them parallel, but I am not interested in voltage, I am interested in current only. So what is this equation? What is the approximation of this? 1 by GM2 parallel RO2.
1 by GM.
1 by GM2, because I already told RO2 is in mega ohms while 1 by GM is in milliohms. So generally in parallel combination, what is the 10k parallel, suppose 1 mega ohm, what you write approximately equal to? What you write?
So is that
What is that?
is that a mega ohm?
Yeah, this is in mega ohms.
Approximately 10k.
10k, small value, right? Smaller value. So out of these two, which is a smaller value?
1 by GM2.
Huh?
1 by GM2.
1 by GM2, 1 by GM2. Now addition is there. What will be this approximation?
R1.
It is the addition, right? So higher value will be dominating. So this is neglected. So what I am getting finally approximately equal to GM1 into V in. And in most hand calculation, this is sufficient. So what is happening now? I out by V in, how much it is? GM1. What is I out by V in is capital GM. So capital GM is the GM of input device, in this case cascode configuration where we have drawn, okay, I deleted it. In cascode configuration, VDD, this is VB3, VB2, VB1, and this is V in. This is V out. So what is gain AV is capital GM into R out. Now when input device in cascode configuration, when the input device is close to ground, capital GM becomes approximately equal to what? Capital GM approximately equal to GM of input device, GM1, GM of this device. And what is R out? GM2, RO2, RO1 parallel, GM3, RO3, RO4. So this is the gain equation AV for cascode. Understood how to deal with the problems?
So
Any
it's,
question?
so it's plus GMR out, not minus, right? Because I thought
Minus. So sign you have to understand. It is a common source followed by common gate, right? So it is a minus. So sign you take care of it. Because it is a common source, gain is negative, common gate gain is positive, negative gain into positive gain is equal to negative gain, right?
yes, sir.
Understood. Now, if you have any question, you tell me before proceeding further.
So why did you take capital GM as small GM1?
So it is approx. So I proved it, na? In hand calculation, most of the time approximations are used. I calculated what is actual capital GM will be I out by V in is equal to GM1 RO1 divided by RO1 plus 1 by GM2 parallel RO2. You solve it, you will get this expression. This is actual expression. But when I put up values, I will not get much difference between this value and small GM1. So capital GM, I replace, this is capital GM, but it is approximately equal to GM1 because this become equal to 1 by GM2. RO1 plus 1 by GM2, 1 by GM2 can be neglected, and then RO1 gets cancelled. So it is GM1. Understood? Understood? Understood it or not?
Yes, sir.
Any question now? Any question? Any question? Any specific doubt is there? Any specific doubt?
Capital G.
Huh?
So, can you go to the cascode?
Saurabh,
Cascode, which one? This
Circuit diagram.
Huh.
Yeah. Here, if the above two transistors are made into NMOS,
NMOS.
yeah,
It cannot be, right? NMOS cannot be used there near the VDD supply. So how you will make it? It is really difficult because if I make them like this, so this is NMOS, right? And then the problem here is it is really difficult to bias them. This is VB3, VB1, VB2, and then VB1. Suppose this case. Now this is interesting. Okay, I will ask you what will be the gain, means what will be R out in this case? What is the impedance looking from this terminal?
1 by GM.
1 by GM parallel RO. Agree? This is M1, this is M2, M3 and M4. Agree or not? What is the impedance? This is connected to ground, right? In calculation of impedance, what is the impedance between these two?
1 by GM4.
1 by GM4. What is the impedance here?
RO4.
1 by GM4 parallel RO4. So approximately how it can be written?
1 by GM4.
1 by GM4. Okay, so I will replace this by 1 by GM4. Approximation, I am using approximation. This is 1 by GM4. Now you are looking from this terminal. Can you tell me what is the impedance? What is the impedance looking from this? I just told you a formula. When you look from the source terminal, 1 by GM4 and RO both should be transferred to the source side. What is the impedance? 1 by GM4 divided by 1 plus GM3 RO3 plus RO3 divided by 1 plus GM3 RO3. Which formula I have used? Which formula I have used? So RD plus RO divided by 1 plus GMR. So RD was 1 by GM4. RO is RO3 of this and then divided by this. So this will be what? R up. What will be R down? Approximate value of R down? GM2, RO2, RO1, right? GM2, RO2, RO1. Agree?
Yes.
Okay. And what will be capital GM? What will be capital GM? This is connected to ground, this is I out. What is capital GM?
Minus GM1.
GM1, small GM1. So you can find out again if NMOS are there, but this is not good configuration. This is not a good configuration, right? NMOS should not be used up. You will study the reasons later on, but should not be done in this way. Any further question?
Yeah, sir, regarding the differential amplifier.
Okay, but okay, I will come to that point, but some student has asked me some questions related to gain calculation. Now, suppose just one example I will take and then I will come to your point. Suppose this configuration is there. VB, this is connected to ground. This is V in, and this is R out, has to be calculated. This is VDD, and this is connected to ground, sorry, through current source, and it has been asked to find out the value of R out. So this is M1, M2. Okay, can anybody tell me how I can write down the equation? What is done to the constant current source in calculating impedance? What is done to the constant current source in calculating impedance, R out?
Open circuit.
Open circuited, right? So this should be open circuited. So what is the impedance looking from this terminal now? See, this VDD is connected to ground. There is a 1 by GM here. There is 1 by RO. Sorry, RO and 1 by GM. Are they in parallel? Because VB is connected to ground, VDD is connected to ground. So what is the impedance RS? What is the impedance RS?
1 by GM2 parallel RO.
1 by GM2 parallel RO2. Even if I apply the formula, what formula I said, RD plus RO divided by 1 plus GM2 RO2, right? What is RD in this case? 0, right? So it is RO2 divided by 1 plus GM2 RO2, right? And if I take RO2 down, 1 upon 1 by RO2 plus GM2. Is it GM2 1 by GM2 parallel RO2? Right or not? So the impedance offered by whole of this circuit is 1 by GM2 parallel RO2. Can you tell me what is R out in this case then? Approximate value? GM1 RO1 into 1 by GM2 parallel RO2. It is acting as a RS, right? This is RS. GM1 RO1 RS is the approximate value, right? Right or not? So this is the value of the R out. That's all. And if I use the approximation 1 by GM1 RO1, what will be 1 by GM2 parallel RO2? 1 by?
1 by GM2.
And if GM1 and GM2 are equal, they get cancelled and the impedance becomes only equal to RO1. So that depends on the approximation. Is it clear how to calculate impedances in this case?
Could you explain the very last part? How you got GM1 R1 into 1 by GM1 parallel R2?
GM1?
The very last
This-
part. Is that, yeah, that one. Yeah.
So that is based on this formula. Na? What is the formula for impedance here? If you look from this terminal, what is R out here? Approximate value? If this is M1, this is RS. GM1 RO1 into RS, right? Approximate value?
Basically, we just transfer the resistance first to the source of M2, then we transfer it to the drain of M1.
M1. So that is actually just way of writing. Means directly you can write. You don't do the transformation on paper. You just write directly. GM1 RO1 RS is the value. So in this case, GM1 RO1 into this resistance, right?
Yeah, got it.
Any question? Any question? Any specific question now?
Sir, you had previously mentioned that if we perform this transformation, we can't apply some method or some formula. I didn't quite catch what you meant back then.
No, what I said is, if this transformation is to be used, it should be only used for calculation of RIN and R out. You should not apply for calculation of gain. Some formula I told you in the class, right? AV is equal to what I said, minus or plus, depends on your configuration resistance connected at the output. Resistance connected at the output divided by resistance seen through the source terminal. So this formula is applicable only when RO is not present. Small RO. If RO is present, then there are lengthy formulas available. Lengthy formulas available for every configuration. For example, I will just tell you, if you are able to remember it, that is quite good. So what is this configuration? V in. This is VDD, this is RD, this is RS, this is V out. Now, in the absence of, if RO is not present, how you write a gain equation? How you write a gain equation?
GMRD 1 plus GMRS.
So resistance connected at the output RD divided by resistance in through the source terminal RS plus 1 by GM. If RO is not present, right? But if RO is
of this, right?
negative of this, so sign I said you
How do
find
we
it.
check the sign?
Sign is common source amplifier always has a negative gain. Common gate and source follower always has a positive gain. Okay.
Okay, sir. Got it.
Okay. Now, if you consider RO, then the gain equation I will be writing. If you are able to remember it, it's well and good. But you should try it out. Minus GM RO RD upon RD plus RS plus RO plus GM RO RS. The gain equation, if RO is taken into account. Looks to be very lengthy, but this factor you know it, right, already. RS plus RO plus GM RS RO, right? So this is for this configuration. Second configuration, this is what? Common source amplifier, CSA. Which is the other configuration?
Common gate.
Common gate. So common gate configuration, it is something like this. So this is VB and you apply V in here. This is RS. This is VDD. This is RD. Output is taken from this point. Okay. Without RO, what is the gain? RD divided by RS plus 1 by GM, right?
Yeah.
Huh? Plus
Without,
RD
you're saying without arrow, right?
without RO. Resistance connected at the output is RD. Resistance in through the source terminal is RS plus 1 by GM, right? Now with RO, the gain formula for it is 1 plus GM RO divided by RD plus RS plus RO plus GM RS RO whole multiplied by RD. Okay, so these formulas have been derived using small signal model by considering RO also. But we don't generally require this bigger formula. Whenever required, I will be using it later on, but not right now. So these two formulas are important. And what is the next configuration that is remaining?
This was common gate.
This is common gate, CGA.
And if the RS is not there, then what will happen?
So you have to, what you have to do? RS should be equal to 0.
So just
So
remove
if there
it
is
from
no-
there.
Huh? What is the problem? RS you put it 0.
Okay, that's all.
And see, it is not practically possible to make RS is equal to 0. You take any voltage source, it has its own resistance, right? So RS will be there in practical circuits, but if you don't want RS, you just put this to 0. So this factor will go away, this factor will go away. So it is 1 plus GM RO into RD divided by RD plus RO.
Sir, is this? Could you tell what it is for without arrow?
Without
Without arrow, common gate, but no.
without RO, it is the formula is same as RD upon RS plus 1 by GM. Positive, gain is positive. So there is no difference between gain of a common gate amplifier and
Also.
common source amplifier.
The magnitude.
Okay? Huh? In
Magnitude.
terms of magnitude, sign is different, but in terms of impedances, they are totally different. What is the input impedance? What is the input impedance of this? If I seen by V in this case, in absence of RO, what is the input impedance? What is the input impedance?
1 by GM.
1 by GM plus RS. And if RS is absent only 1 by GM. Only 1 by GM, right? And in case of common source amplifier, what is the input impedance? Input is applied here. What is the input impedance?
Infinite.
Infinity.
So that is a major difference we have between common source amplifier and common gate amplifier. Even their gains are relatively similar, their input impedances are totally different. Okay.
Sir, I had a question. So whenever we're looking through source, we can automatically assume that there is a 1 by GM connected, even though it's not actually there. We just use it and for convenience, and we put it in series with whatever source resistance is there.
Yeah.
Okay.
Okay, so that depends on whether you are looking from here or you are looking from here.
Right. Got it, sir.
Okay. Somebody was asking question. The configuration was, it is a really interesting problem and you should understand. Suppose I have something like this. Suppose RS and V in is applied here. Okay, and output is taken from this point. VDD, RD, RS. Input is applied, this is VP. Now, if I ask you, what is the gain of this circuit? 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 Yes?
So we might have to do it like finding the GM and
Now the issue here is this RS going to play any role in the circuit operation? Suppose if I open it here and try to find out what is the Thevenin's equivalent of this circuit. What is the Thevenin's equivalent consist of? This is your V in and this is your RS which is connected to ground. So open circuit voltage is Thevenin's equivalent voltage, right? Right? Open circuit voltage is the Thevenin's equivalent. What is the open circuit voltage now?
V
in. So VTH is equal to V in. And what is resistance? RTH. What is the method? All voltage sources should be short circuited, right? And find out what is the current. You should apply the known voltage source and find out what is the value.
RS.
RS, how it is? It is short circuited, na? This is short circuited.
Okay, right. So 0.
0. RS is not there. So RS will not play part in the calculation. Okay? Got the idea? You should always remember that when you have voltage source, if you put any resistance across it, it is ineffective in the calculation. It is only for drawing the current, but it is not going to be a part of a. Similarly, when there is a current source in series with, if you put any resistance, that is not going to play any part in the circuit. So the gain, because what is the VGS? Can you tell me? Suppose this is in gain calculation. What is VGS? What is VGS for this circuit? Is it difficult question? VGS. What is VGS?
So VB minus V.
Huh?
Minus V.
VB minus V.
Minus V. What current will flow in this direction?
GM into VB minus V.
V in VB is connected to ground. Na? VB is a constant voltage. In gain calculation, it is connected to 0. V in into GM, right?
And negative.
V in negative. And to make it positive, I have done change the direction. This will flow to RD. What will be V out? What will be V out? GM into
GM RD.
GMV.
RD. So what is V out by V in? GM into RD. This RS is not going to come into picture. But if I ask you what is the input impedance for V in, what is the input impedance looking from this side? What is the input impedance looking from this side? It is 1 by GM parallel.
Sir, could you just tell where you are looking from?
You are looking from this side here.
1 by GM parallel RS.
Parallel RS.
1 by GM parallel RS. So input impedance is 1 by GM parallel RS, but the gain is only GM RD. Okay? Okay?
Yes, sir.
Any other question now? Anything that I have not covered? Anything that I have not covered? Anything that I have not covered? Somebody was asking question related to differential amplifier. What is that?
Yes, sir. I wanted to know how you calculated the relation between VN1 and VO2 while finding the gain.
Okay. You mean to say which method? Thevenin's equivalent method or the method that we have seen in the last lecture?
No, the one which we saw in the last lecture.
This is V in 1 and V in 2. What is the relationship I said? They are equal in magnitude, opposite in direction. Okay?
Sir, VN1 and VO2.
V in 1 and
VO2, like when we consider only one source and isolate the other.
okay. So this is VO2 you are saying.
Yeah.
This is VO1. Okay? So this I done to simplify the analysis. I have done it in the absence of RO. Absence of RO. Even if you consider RO, it is not going to change much. Only the calculation will. I will sometime whenever I have a time, I will do that calculation completely. Okay. So what should be done in calculation of gain? I said V in 2 should be connected to ground, right? I have to find out what is the effect of V in 1. So how V out will be VO2 will be calculated because of V in 1. Okay. So what I have done is I want to replace this complete circuit by its Thevenin's equivalent. So remember that for gain calculation, VDD is also connected to ground. This is RD. Okay. I want to calculate what is the output here. So this is connected to ground. This is V in 1. Okay. And I want to find out what is the V Thevenin's equivalent voltage. It is not threshold voltage. It is a Thevenin's equivalent voltage. And what is RTH? I have to find it out. Okay. Now, in order to calculate V Thevenin's, what I will assume is, because now writing gain equation becomes really difficult. So I will consider here dummy resistance Rm. And later on I will substitute by infinity, because it is not there means I can replace it by infinity. Now, in this case, can you tell me what is the gain of the circuit? Which is this configuration? Which is this configuration?
So common source.
Common source. What is the resistance connect? So RO I am neglecting, RO I am not taking. What is the resistance connected at the output terminal? REM, right? Resistance connected at the output terminal is REM. And what is the resistance seen through the source terminal? What is the resistance seen through the source terminal? REM plus 1 by GM, right?
Yes.
REM plus 1 by GM1. REM plus 1 by GM1 is my gain. What is the gain? VTH, Thevenin's equivalent voltage divided by input voltage V in 1. But what I have taken additionally here? What I have taken additionally? REM. I want to place it by infinity. If I put REM is equal to infinity, what is going to happen? First I should divide it by REM. So 1, here it becomes REM. And now if I put REM equal to infinity, what is the value? 1 by? Huh? So what is Thevenin's equivalent voltage? What is Thevenin's equivalent voltage? V in 1. Agree? Agree or not?
Yes, sir.
And what is RTH? What is the resistance looking from this terminal? What is the resistance looking from this terminal?
1 by GM.
1 by GM1. So I will now replace this whole circuit by its Thevenin's equivalent circuit. So I will delete this. So what is Thevenin's equivalent circuit? Resistance in series with Thevenin's equivalent voltage. This is VTH, which is equal to V in 1, and RTH, which is equal to 1 by GM1. Now you tell me, what is this configuration? I want to find out VO2. VO2. What is this configuration?
Common gate.
Common gate. What is the resistance connected at the output? RD, right? Right or not?
Yes, sir.
What is the resistance in through the source terminal by V in? 1 by GM1.
Plus 1 by G.
1 by GM2 is VO2 by VTH, which is equal to V in 1. Okay, so what is VO2? Because of V in 1, RD divided by 1 by GM1 plus 1 by GM2 into V in 1. This is because of V in 1. And what is the relationship between GM1 and GM2 in case of differential amplifier?
Same.
They are same. So I can replace this by RD upon 2 by GM into V in 1 GM RD divided by 2 into V in 1. Got it?
Yes, sir. I had a doubt. Like in this, we have found out the Thevenin equivalent for transistor M1. Why can't we find it for M2 and then use VO2 as the source in transistor M1? Like then it will.
So what you are doing? Basically, you have to apply the how you will find out Thevenin's equivalent of M2. So my question is, how you will find out Thevenin, even without knowing V, so this is already connected to ground, right?
Yes.
And this is V in 1. So you have to find out the effect of V in 1 here, right?
Yes.
So how I can replace this by its Thevenin's equivalent without knowing what is the input to it?
Okay.
Right? Now,
So like in this, the one which you have drawn, I can't replace the encircle thing with 1 by GM2 and then take it in the source of transistor M1.
regarding what? So when I have to find out V in 1, VO1, then I can replace this by its resistance because its gate is already shorted, right?
Yes,
So what is the impedance looking from this?
1 by GM2.
1 by GM2. So I will replace it by its resistance now, not by Thevenin's equivalent, because there is no input voltage source now. 1 by GM2. So what is VO1 divided by V in 1? Minus RD upon 1 by GM2 plus 1 by GM1. So same thing I have done for calculating relationship between VO1 and V in 1.
Yeah, sir, that I got it. What I did was like here where you have shown 1 by GM2 and where it is rounded, I put VO2 over there and then connected one more.
VO2 is output voltage, na? It is not input voltage.
Okay, okay.
It is what is called the effect, not cause.
Okay, sir.
I am not applying the external voltage as input, VO2. It is output voltage generated by the amplifier.
Okay. Okay, sir. Got it.
Yeah. Any other question?
So,
Ah.
so I have a doubt in the previous question which you solved, the one which had RS one.
Which question?
So the one,
Yeah.
V out.
Yeah.
So here, so the formula for gain is resistance as output divided by resistance in through source, right?
Source terminal means resistance in by V in.
Yeah, that's right. So resistance by V in, why won't it be 1 by GM parallel RS?
It is not parallel because, see, when you connect a voltage, what is the purpose of this whole exercise is, what is the input voltage that is causing a current that is flowing through M1, right?
Yes, sir.
So what is responsible for it now? It is the voltage across the gate source of M1.
Yes, sir.
Is it dependent on RS?
No.
It is not dependent on RS, right?
Yes, sir. Not.
So RS will not come into picture for a gain calculation.
But earlier in the lecture, so we solved a similar question where we had taken R naught into the consideration, and you said the R out from there, that point would be RS parallel GM plus R naught something. Why not the same thing applies there also?
No. I said whenever you connect any resistance in parallel with the voltage source, its Thevenin's equivalent says that resistance doesn't matter. If you remove it, the circuit is not going to be affected.
Oh, okay. So here the R out through source would be just 1 by GM, right?
R out through?
Through V in, basically V in.
No, it is RS parallel 1 by GM2, by GM1. For resistance calculation, because see, V in is supplying two parts of the current. One is going down and one is going up. Which is responsible for creating output voltage?
The one which is going up.
Going up. So for gain calculation, that will come into picture, means RS will not come into picture. But for input impedance calculation from V inside, it will be RS parallel this 1 by GM.
Okay. Yes, sir. I understand. Thank you, sir.
Okay.
Sir, I have one doubt. So in an NMOS transistor, the VDS is equal to VGS minus VT, right?
Yeah.
The saturation minimum case.
Saturation, VDS, minimum value of VDS is VGS minus VTH.
Yeah. So what would you do for a PMOS transistor?
Same condition, but the relationships are VDS should be greater than or equal to VGS minus VTH. So VDS, this value is a minimum value.
Okay.
Okay, and for PMOS, it is VDS should be less than or equal to VGS minus VTH. So VDS is equal to VGS minus VTH.
So it's the exact same.
Okay, so same, but the relationship is different, right? This is
Yeah, yeah. That's the upper value. This is the lower value.
lower value.
Okay.
Okay.
Yeah.
Okay. Any other question? Okay, so if you have any other doubts, you please mail me. I will see it. I will try to look into it and then see how it can be dealt with. Okay. Thank you. Any question?